Today we're going to look at section 8.3 of our notes, which covers the law of cosines. Now the law of cosines is very similar to the law of sines in that it has a relationship between the angles and sides of a triangle. We've got that large triangle drawn on the right here. It's triangle ABC. But to develop the derivation, we need a few other components to this. We're going to look at the triangle on the left first, and we're going to split this into smaller components. Looking only at the triangle on the left, we can use the Pythagorean theorem to come up with a relationship between side x, side h, and side c. So we know that the hypotenuse squared, c squared, would be equal to x squared plus h squared. Solving this for h squared gives us h squared equals c squared minus x squared. And that's going to be our first substitution. The next piece of this is also based upon the triangle on the left, and we know that the cosine of angle A is equal to the adjacent over the hypotenuse side. So cosine of A is equal to side x over side c. Multiplying both sides by side c gives us x is equal to side c times the cosine of angle A. This is the second substitution that we'll use in the formula. Now looking at the triangle on the right, we need to label a few things. We're missing one of the side lengths. This side length on the bottom here, if we know the entire length of side AC is equal to B, and we know that the side length on the left is equal to X, we can simply take the difference of those two sides to figure out the length of side CD. So if we're going to label this, we're going to say that this is the whole length B minus X. And looking at the triangle on the right, looking over here, we can figure out the Pythagorean theorem gives us a relationship a squared is equal to h squared plus the quantity b minus x squared. Let's expand this out. This gives us h squared plus b squared minus 2bx plus x squared. And at this point, we can make some substitutions here. We know what h squared is equal to, and we also know what x is equal to. So we can substitute in for this x in the middle. You'll see the other one will be reduced out in a minute. Let's substitute for h squared. We get c squared minus x squared plus b squared minus 2b, and I'm going to replace the x with c times the cosine of angle A. And you see right away that there's a few terms that drop. The x squareds, negative x squared plus x squared is 0. So we can write this as c squared plus b squared minus 2bc times the cosine of angle A. And that is what a squared is equal to. We're going to put that formula in our box down here, and I'm going to rewrite it just in alphabetical order. A squared is equal to b squared plus c squared minus 2bc times the cosine of angle A. Now let's label this triangle down here. I'm going to say this is angle A. Opposite angle A would be side A. Angle B up top. Opposite angle B would be side B. And angle C and side C respectively. To come up with the other relationships, understand that a squared is equal to b squared plus c squared. Those are the two sides that are not a. So we're going to do the same thing here. B squared is going to be equal to a squared plus c squared. Those are the two sides that are not b. Minus 2ac times the cosine of the opposite angle b. For the third formula down here again, the two sides that are not c are a and b. So I'm going to say a squared plus b squared minus 2ab times the cosine of the opposite angle, c. Now there's a special case of the law of cosines, and that occurs when the formula for one of the angles is equal to 90 degrees. So if one of the angles is 90 degrees, let's draw this triangle. And we're going to say that this right angle here is angle A. Side A opposite, we'll call this angle B, which makes this side B opposite of angle B, and angle C and side C. Now if we write the formula for law of cosines, a squared equals b squared plus c squared minus 2bc cosine of A. The cosine of 90 degrees, let's replace angle A with 90 degrees. We know the cosine of 90 degrees is 0, so this whole term here is going to go to 0. That leaves us with a squared equals b squared plus c squared, which should look very familiar to you as it's the Pythagorean theorem. We're going to use the law of cosines to solve two different types of triangles today. The first case that we have is to solve a triangle with side angle side information. So two sides and the included angle. So we're going to draw a picture to illustrate this situation over here on the left. We've got angle C is 110 degrees. That's obviously an obtuse angle. So I'm going to say that this is angle C down here, and this is 110 degrees. Side C is opposite angle C, and we'll say the angle between these two is 110, so this must be side B, or on the left we'll label this 110, and that makes this angle B, and angle A gives us a 16 unit length over there on the right. So we're going to try and solve this triangle, and we're going to use the law of cosines to do so. The first thing we want to find is side C. So we're going to set this up and use a law of cosines here, so we can write the law of cosines right away. C squared is equal to a squared plus b squared minus 2ab times the cosine of angle C. And we're going to substitute what we know. We know side A is 16. So we'll say c squared equals 16 squared. Side B is 10. Minus 2 times side A, which is 16. Side B is 10. And the cosine of 110 degrees. If we simplify this with a calculator, we wind up getting approximately 465.45. Make sure you use this answer in your calculator and do not round off. Square root both sides, we get c is equal to, it's approximately equal to, let's use approximately equal to symbol, 21.574. And notice it's not plus or minus. C is a positive length. We're going to leave it as only a positive number here. So we found side C. Next thing is to find one of the angles. So we need to find one of the angles. It doesn't matter which one necessarily. Let's find angle A. And to do that, we're going to use the law of cosines again. We'll use a squared is equal to b squared plus c squared minus 2bc cosine of A. Now notice that we want to solve for angle A, so it's better to solve the formula ahead of time. I'm going to put the 2bc cosine A on the opposite side to make it positive. And I'm going to put the a squared on the other side as well. Last step to solve for the cosine of A is to divide by 2bc. So the cosine of A should be equal to b squared plus c squared minus a squared all over 2bc. This formula right here you should know. You're going to do this enough to where you probably want to memorize this version of the formula. So cosine of A is equal to b squared plus c squared minus a squared all over 2bc. We make our substitutions. So we have 10 squared. C squared winds up being 465.45 from the previous problem. Minus 16 squared all over 2 times b, which is 10, and c was 21.574. And again, make sure you use the previous answers when you can. This is the cosine of A. And this gives us, on a calculator, cosine A, if you simplify this whole right side, 0.7172. And if you take the arc cosine of both sides, you can solve for A. And we'll say A is approximately equal to 44.180 degrees. And again, just please make sure you're in degree mode for this on your calculator. So we've got A. We have one missing side, we're missing angle B. And we can use the fact that the sum of the interior angles of a triangle sum to 180 degrees. So we can say angle B is equal to 180 minus 110 minus 44.180. And this gives angle B is equal to, or approximately equal to, 25.82 degrees. And we've solved our triangle.